Workstation or DDW. One of the primary questions I get is, Chet, how do you get eMotion data to another program on my computer? Or can I stream eMotion sensor data to computers that are on the same network? And the answer is yes. So I will go ahead and demonstrate sending raw network data via UDP, and I will also demonstrate the Open Sound Control module. So going to go ahead and open up a previous project that I'd constructed in a tutorial. And if you have any questions up to this point about creating a new project from scratch using the eMotion modules, you should see that previous tutorial where I make this from scratch. And so you'll recognize immediately the eMotion Fuse module right here, and it appears up in the top right-hand corner of the screen usually. Now, how did this open? At the beginning, I have a load bang connected to an open message, connected to P control, and this goes into the dummy inlet in my eMotion Fuse object. And this just ensures that upon initialization of my project that this module pops up automatically. Now, I've already plugged in my eMotion Fuse into the USB port, as indicated by this USB serial object coming up in my list of available devices. You'll also see this mod audio gain that I made in a previous tutorial with the receiver object, and this populates in the output list of your Digital Data Workstation. This is familiar, but I've also added a couple new objects. I added a UDP receive 7400 and a UDP receive 7450 C in MAT, and I will get into what these do in just a moment, but let me go ahead and draw your attention to the eMotion Fuse module here. And on the window in the right hand side I have IP and port, and my IP I went ahead and set to 127.0.0.1, which also indicates localhost, and a port of 7400. And I want you to notice that this number here is also the same exact number port for my UDP receive argument or parameter. So I'm going to go ahead and open up a new Digital Data Workstation. Actually, before I open up my Digital Data Workstation, I'm going to turn on one of my emotes, my Discover 7 emote to be exact. Oh, and I want you to notice that it's not popping up because I forgot to do one thing, which is turn on my serial object. So I want you to notice now that I've turned on the serial object, and I've opened up my Jenna 7 or my Discover 7 module with an ID of 0, you should recognize here. The top 3 tracks, as from a previous tutorial I described, are the built-in accelerometer axes. Track 4, I have attached a force-sensitive resistor. And remember, your sensor data is going to be quite noisy and chaotic until you use your sensor over its full range of voltage, whether that be pressure, light, breath, whatever. And this is because this is a sliding calibration model. I'm going to go ahead and turn up the filter here, filter variable. So the closer to 1 I get, the more intense the filtering function will be. So you can see I have super smooth and slow data right now at 0.8. I think 0.5 to 0.7 really is the sweet spot for force-sensitive resistor. I'm also going to turn on the spring module as well, because maybe I want that data. Alright, next step is, now that I have the emotes on the network that I want to work with, I'm going to open up my Digital Data Workstation. And this is still a little bit buggy. I want you to notice it says number of tracks 1, and if I create a new track, it gets created somewhere down here, and number of tracks 2. Well, that's not right. So go ahead and hit delete until you get to 0. We're going to fix this in a future version. And I just created a new track, and I'm going to select my force-sensitive resistor, which happens to be on the 4th channel. They're labeled in order of letters of the alphabet here. So D, and I'm going to choose the filtered version because I want the nice smooth, check that out right there. And next, let's go ahead and pipe our data track output to our network. And so any computer over a network connected to this same network as this computer can have access to my data tracks. And the first one I want to demonstrate is NetRaw. So NetRaw just simply uses the UDP protocol. It doesn't use any of the open sound control protocol at all. And this is quite useful. So let's go ahead and go back to our project, which is my project here. And I want you to notice that in this window here, UDP receive 7400, as I squeeze my force sensitive resistor, that this number automatically changes to correspond with that. So there we go. And this is very important. 7400 is the argument here. If I change this to 7401, notice how the data stops percolating, and that is because the port here on the eMotion fuse needs to be the same port for any computer that is going to have access to this data. Now, you also, let's say you want to pipe it to another computer, your destination IP would be that computer, that remote computer's IP address. So it might be 192.168.0.1, for example. Whatever the IP address of your destination computer is going to be. This happens to be local port, which is why I'm getting the data here. All right, so straightforward enough. Let's go ahead and take a look at open sound control. And to receive open sound control data in MaxMSP, you need to have a UDP receive with a parameter specifying your port number, 7450. I'm going to go ahead and change that to it right now, 7450. And I want you to also notice that there's a special thing here called C and MAT. And that just tells UDP receive to accept the full packet data from the open sound control protocol. Notice how it's going into an open sound control object, and this is necessary in MaxMSP because we are unpacking this open sound control packet, data packets. And take a look at this. Even though I have NetRaw happening here, I am still receiving 7450. I'm going to go ahead and select NetOSC. And this is a special output destination because inside of the eMotion fuse I actually have an open sound control object that is converting all this data into eMotion messages. A very special thing to notice is once I've selected NetOSC as my output, I want you to notice that my data has a directory prepended to it, /eMotion. I also use the word index. I like to index all my data so I know where it's coming from. Now, I'm going to face you with a special dilemma, which is, what if I want several data tracks to communicate over a network, and I want each track to maintain its own identity? And I'm going to show you the problem right now. I'm going to create a second track. I'm going to have the spring mass version. So Jenna D, spring mass number 3, which is the nice sort of loose, springy mass. And just so you can see where that's from, that is right here, the spring mass module. Okay, you can see it bobbing up and down along in the data track. And I'm going to want to send this out NetOSC as well. And I want you to check out what the problem is here. That I'm actually getting 2 streams of data, and it's not differentiating at the destination between those 2 forms of data. All we know is that it's coming from eMotion. So how do I give my individual data tracks their own identity? Well, there's a special thing in rescale. So in data track number 1, let's go ahead and go to rescale. And there's a special thing here called OSC index. This is where you can / and name all of your stuff. So I'm going to call this /filt. I'm going to call this one / you guessed it, spring. And this is all arbitrary. It doesn't matter what you name it. But the important thing here is I want you now to notice that I have 2 data sets, one /eMotion /spring, and the other eMotion, and then /filt. And then I'm going to simply just create another OSC route object with fillet and spring. I'm going to plug the output into here. I'm going to run the output of fillet into that one and the output of spring into this one. And now I have access to my individual data sets, my individual data tracks. Thanks to the rescale open sound control thing. Now, let's say you don't want this anymore. All you have to do is delete the index, and it automatically just sends raw data. And so I want you to notice now that I'm only receiving spring data, and then I'm going to connect the outlet to all other things that are not attached. Well, I guess that's not working either. Oh well. So just know that the raw data has to be, indexed here. And there you go. Thank you very much for watching.